Okay guys, it's going to be a quick recap on number patterns. Basically just arithmetic and quadratic is what I want to sort out first up here. So it's going to be arithmetic, just denoting it by AS. What we need to know is Tn is equal to A plus your difference into n minus 1. Obviously, we do know that this is the term value, this is the first term, this is the difference, and this is the term number. Now, all we're going to do is let's put a basic one, 8, 3 minus 2, and so onwards. And what we're going to do now is just basically find out what the term or the general term for this is. So the general term is basically the Tn formula. That's what we need to know. All right, so it's just going to be Tn. The A value is 8 plus the difference, and obviously here the difference between, we always take it from term 2 minus term 1. The difference here is going to be minus 5. So we put that as, actually we can actually put that there because it's going to be the difference that we're dealing with now as minus 5 into n minus 1. Okay, so when you do this, I would suggest actually doing it like this here. You use the actual formula. So let me actually write the formula out for you. Then we can put everything inside rather. I don't want to confuse anyone. So d into n minus 1. So the A value, like we said, the A value is 8 plus the difference, which is now minus 5 into n minus 1. And then we have it as 8 minus 5n plus 5. And what we are left with is essentially minus 5n plus 13. That's it. That's our TNR general term. Then obviously, if you wanted to find, let's say, the 20th term, let's say we want to find term 20, all you're going to do is you're going to take that 20 and sub it in place of n. So your 20th term would essentially be minus 5 into 20 plus 13. And that's it, done there. That should be an easy one. So minus 5 times 20 plus 13 is going to give me minus 87. Minus 87, done. Okay, so that's just taking us back to our arithmetic sequence. However, an introduction into what we're going to be doing this year is an important concept of an SN formula. Now, an SN formula basically tells us the sum of this particular sequence till a particular value, for example, right? So what we're actually going to do here is the following. Is we are going to do this. We are going to find the sum of the first 3 numbers manually. We'll find the sum of the first 3 numbers manually, right? So what is 8 plus 3? What is 8 plus 3 minus 2? So you can put that as simple and easy. You can say, okay, it's going to be 8 plus 3 minus 2. So if you want, you're more than welcome to use your calculators, which is just going to give us 9, and that's done. So that's the sum of the first 3 terms. However, when it gets a bit more complex, you're going to actually have to use this beautiful formula over here, which is going to assist us in calculating the sum of a particular linear or arithmetic sequence. So watch this. So here, we're going to have it as Sn. We're going to find the sum of the first 3, because we only have 3 terms so far. We only have 3 terms so far. So 3 terms. And our A value is still the same. A value is still going to be 8. Plus the difference of minus 5. And how many terms are we dealing with? Like we said, we are dealing with 3 terms. So 3 minus 1, and that's it. So if you put this whole thing in your calculator, you can put it as 3 over 2. Into 2 times 8 plus minus 5 into 3 minus 1. And then close that bracket. And you're going to get 9 as we had before, just to make sure of it, yeah? So that's where we're going to use this new concept of sum of an arithmetic sequence. Just one more example to this thing would be, let's say we had the following sequence. Let's say we had 35 plus 38 plus 41 and so onwards, and we wanted to calculate, we'll call this example 1, we wanted to calculate the first, oh sorry, calculate the sum of the first 12 terms. So all you do is you're going to use the same formula. Sn is equal to n over 2 into 2a plus d into n minus 1. It's just so you guys get used to this formula essentially. So our a value is still going to be 30, well, it's going to be 35, and then comes the difference situation. So 38 minus 5 is just going to be 3, so we know it's a positive 3 for our difference value there. So it's going to be this Sn, we know it's 12 terms, it's 12 over 2 into 35 plus a difference of 3 into 12 minus 1, and that's it. So we plug that into our calculator and we are pretty much sorted out. So let me just make sure I close that. So we should get it as 618. That should be our sum of the first 12 terms. Right guys, I hope that makes sense for this formula. Like I said, it's a very important formula to understand for this year. There is one more that we're going to be doing in our class, which is going to be this one here, which is n over 2 into a plus l.
By understanding this formula a little better. So this formula is an important formula because if we have a particular sequence, let's say we have a sequence of 2, 5, 8, so onwards, and let me just get what the last term would need to be. Okay, so let's say it's 2, 2. So 44 is what we're going to put our last term as. Right, so that's what our last term is. And if we would like to find out what the sum of the sequence is, simple. Same rules still apply. This A is still going to be our first term. L is going to be regarded as our last term. Right? And N is the number of terms that we have in the sequence. So that's going to be important. For now, we know what our first term is. We know what our last term is. We just need to figure out how many terms are in the sequence. So that's what we're going to sort out first. So remember, this is a linear or arithmetic sequence. So that's what we're going to sort out first. We're going to say Tn is equal to a plus d into n minus 1. If you have any other formulas for arithmetic, you're welcome to use it for normal arithmetic sequence. But that's the one that I always use. So your a value is going to give you 2. Your difference is you're continuously adding 3 into n minus 1. And your last term is 44. You take it over, that's 42 is equal to 3 into n minus 1. We're going to have this as 14 because I'm going to divide by 3. Take the 3 over and divide, and then I'll get 14. So 42 divided by 3 is 14. N minus 1, n is equal to 15, and that's done. Now, what we need to do is we're going to use our Sn formula to sort this out. So what will normally happen, and when you use this formula, is when they give you the first and last term, and you just go and calculate the sum of that series like this here. So Sn is equal to n over 2 into a plus l. And what do we have here? Simple. We have 15 terms in total over 2. Our a value is 2. And our last term is 44. We put this whole thing in our calculator and we're done. So 15 over 2 into basically 46, but we'll put it as 2 plus 44. And that's 345. There we go. So the sum of the first 15 terms is 345. Perfect. Now, what we're going to do is, let's go and test this out with the previous Sn formula, right? So we can just go and confirm it. We can say Sn is equal to n over 2 into 2a plus d into n minus 1. And let's just go and sub in all of the values. So 15 over 2, 2 into 2, difference of 3 into 15 minus 1. And I promise you, you put this in the calculator, you're going to get 345. Sorts it out. Okay, now on to the next thing, which is going to be showing you how to calculate term numbers. So how do we get these term numbers but from an SN formula? Let's go and make sense of that now. All right, so here we go. Let's say we have, okay, so first let me do an example sort of thing for this. Let's say we have, let's say we start off with 1, okay, no, 1 is fine. 1, 5, 9, 13, and so onwards. Okay, so this is just a normal arithmetic, again, linear sequence. And what I want to introduce you guys to is like a logic, I wouldn't say a logic pattern, but it's more of a way to think, right? So I want to figure out, if I'm given an SN formula, how do I find our term values? So we're going to make sense of this now. So our term 1 is basically equal to the sum. Actually, let me do it like this. Let me say that the sum of the first term is equal to term 1, right? Because you know that it's going to be, if you sum 1 up, it's just going to give you 1, and the first term is basically 1. Now, let's pay attention to the next one. Now, how do I get to 5 using the SN, using sum formulas, right? So what I can do is, I can say that the sum of the first two terms minus the sum of the first term is equal to term 2, right? Now let's show you this. 1 plus 5 is 6, right? 1 plus 5, the sum of 2 is 1 plus 5, which is 6. And then the sum of 1 is just 1. So I'm going to say sum of 2 minus the sum of 1. Remember, sum of 2 is 6. The sum of the first 2 is 6. The sum of the first one is just 1. And what is that going to give me? That's going to give me term 2, which is just going to be 5. Now, the same would work. Sum of 3 minus the sum of 2 is equal to term 3. And now you watch this now. Sum of 3 is 1 plus 5 plus 9. So 1 plus 5 is 6. 6 plus 9 is 15. So we have this as 15 here. Then the sum of the first 2 is 1 plus 5, which is 6. And then 15 minus 6 is going to be equal to term 3, which is 9. Done. So in general, it's the following. Sum of n minus the sum of n minus 1 is equal to Tn. Right, that's the general form. So let's go and take any particular sequence, really, and just show how that's going to work. Let's take, let's say we have 16, 21, that would be 26, and so onwards, and then that would, well, I don't have to show any others after that. That should be easy enough. So that's, okay, actually, sorry. We're not going to do that. What we're actually going to do is we're going to actually use an SN formula for this. So we're going to say Sn is equal to 2n squared plus 3n. So they give you this here, and they want us to calculate. They give you this and say we need to calculate the value of term 8. So the value of term 8 is actually going to be the sum of the 8th term minus the sum of the 7th term is equal to term 8. So sum of 8 is actually pretty simple. It's going to be 2 into the 8 squared. So it's 2 into n squared, obviously. So 2 into the n squared. But remember, n itself is going to end up being 8 here. So it's going to be 2 into 8 all squared plus 3 into 8 minus, typically I'd put it in brackets like that there, 2 into 7 squared plus 3 into 7, close that, that's my term 8, and that's done. So you put the whole thing in the calculator, 2 into 8 squared plus 3 into 8 minus 2 times 7 squared plus 3 times 7, and we close that there and we should be good. So 33. So term 8 is actually equal to 33. That's an important thing to understand, just to get into the habit of knowing how to go from an SN formula and get a term value. We'll say it's some sort of arithmetic series, and what we have is, let's say they tell us that term 4 is equal to 25, and then we can say that term 11 is equal to 81. And what we need to actually do now is we need to calculate the general term. The general term. If they say general term, it's basically the TN formula, right? They want the general term, they want the TN formula is what they want. So how do we start off with this here? Simple. You need to know that term 4 itself, term 4 can be written as the following. So you know Tn, so term 4 would be equal to A into your difference into n minus 1. So n minus 1 would be 4 minus 1, which is basically A plus 3D now. Because 4 minus 1 is 3, so that's 3D. So something to get into the habit of knowing is that, term 4 is A plus 3D. Term 5 would be A plus 4D. Term 6 would be A plus 5D. So obviously term 11 would end up being A plus 10D. Right? That's just an easy concept to understand. So what we're going to do here is we're going to end up using a simultaneous equation to sort out our general term. Right, let's get into this here. So now that we know that term 4 is basically term 4 is equal to 25. Term 4 is basically A plus 3D is equal to 25. On this side, we know that term 11 is equal to 81, and term 11 is basically A plus 10D, which is equal to 81. And now we have a simultaneous equation. We have two equations with two unknowns. I'm going to make A subject to the formula on both sides. So I'm going to have it as A is equal to 25 minus 3D. And I'm going to have it as A is equal to 81 minus 10D. Equation 1, equation 2. Let's sort this out. So 25 minus 3D is equal to 81 minus the 10D. And now we're going to take it over and sort it out. So we'll take the minus 10. I'll take the minus 10 onto that side to make it a positive, which means that's going to end up being minus 3 plus 10, which is just going to give us 7D. And then we're going to have it as also, I need to write better than that. 81 minus the 25 is 56. 56 divided by the 7 is just 8. So 8 is what we have as our difference. How do we find our A value? You take that and sub it into either one of those equations. So I'm just going to say 25 minus 3 times the 8, which is just going to give me an A value of 1. Right, so what do we do from here? Simple. All we're going to sort out here is how do we find the general term knowing the A and the D value? You're done. Tn is equal to an A value of A plus D into n minus 1. A value is 1, difference is 8, and that's n minus 1. So that's going to be n minus 1, and what you do from here is that's going to be 1 plus 8n minus 8. Eventually you end up with 8n minus 7. That's our Tn formula. Now you can double check it. You can substitute 4 and see if you end up getting 25, and you can substitute 11 to see if you end up getting 81. So 8 times 4 minus the 7, 25, wonderful. 8 times 11 minus the 7, 81, perfect. We are on track and done. Okay, so sigma notation. Let's get started here. Sigma notation. I'm going to draw the first one fairly neat, or neat for my standards. Okay, so that's sigma notation. I shouldn't say notation, but that's sigma itself. Sigma basically represents the sum of a particular sequence. So you start at the bottom, n equal to normally like any number. It's normally where you start off with your particular sequence, your term number for that particular sequence. So I'm just going to do the easy thing, start off with term number 1, or term 1 I should say, ending at term, let's say 17, and we have this as 3n minus 5. So what exactly is the sigma notation? Well, sigma notation basically represents the following. It represents, first up, your Tn formula. So what's next to, well, this represents the Tn formula over there. This is the term number that you start off with. So it's normally just saying your starting point. That's your term number that you start off with. So you don't have to start from term 1. You can start from term 0, for example. You can, or term number 0. You can start from term number minus 1. You can start from term number 3. You can start from term number 8. It doesn't matter. It's just your starting point. It's basically saying that you normally start with n equal to 1, but now I'm saying that you're allowed to start with n equal to 0. You're allowed to start with n equal to 3 as your first term. So that's just explaining that there. And at the top is basically the end term, the last term that you're going to be able to have in this particular sequence, or the sum of the sequence.